Hey, it's Ryan Hanks here, and Mike Long as well. Our final product circuit is basically a circuit that compares the difference between two in-phase waves, and then if the difference is above a certain threshold, it triggers this LED. So first we have an op amp and two voltage followers to set up the signals, and then those two signals go into this differential op amp, and then the diode is a half-wave rectifier, and it takes the positive side of the difference between two waves, and then it goes into a Schmitt trigger, and if it is above a certain voltage threshold, it triggers this LED, and then microcontroller waveforms.
So here's our two volt input voltages right here. You can see one is 5 volts and one is 1 volt. And so from there you can go to our scope, which is also attached to our diode, and you can see that when the voltages are have a correct difference between the two, they go up and it triggers the LED to turn on. And then when the difference between them gets too close, or the voltage is negative, which is why there's a longer period here, then the LED turns off. So from here you can basically set the threshold for the Schmitt trigger by just adjusting the resistors and the rail and the two power sources. So for ours, we just chose 2 and -2 volts for the power sources, and then a 5K resistor and a 1K resistor here. And so also, if you change the waves then from 5 volts to a smaller difference, so if they're the same, you can see that the LED does not turn on, and then our waveform is just a flat line. And then when you go back to a difference of, let's say, 4 volts, yeah. So just keep them in phase, but then you go to a difference of 3 volts. You can see the LED comes back on.
Yeah, and just a side note is we didn't use an amplifying differential op amp, just the pure difference between the two waves, because we didn't need to amplify the signal. Yeah, that's our project. Thanks for watching.